friends, MoNaCo here.
And Milks.
We are still in atomic theory, getting close to the end. We're making models of atoms, and we're making them simple today.
Seriously.
Yeah. We're walking through page 27 in your packet. We're talking about Lewis dot diagrams. These are going to be really helpful if you're trying to draw up models of atoms and you don't want to draw all those circles for Bohr models.
Right.
And
so what's nice about this is this might be the simplest way to draw these things.
Atoms.
These atoms. But it's also the most useful for everything we're going to do for the rest of the year.
Right.
So we don't have to describe the entire atom. Especially when we're going to get into bonding and such.
We really just have to describe how the outside, the valence electrons behave to make ions and reactions and stuff like that. Correct. So we're going to make your life a lot simpler. Don't forget what you already learned, because that's important too, but we're making a part of things a little bit simpler. Electron dot diagrams, it's the same as a Lewis dot diagram. Lewis was the scientist who first started doing it widespread so we put his name on it, but they're really called electron dot diagrams. Most common description, they show the element symbol and valence electrons. So the two most important parts of the atom it tells us about.
Right. So we're going to do chlorine as our first example.
So
first rule. Sorry I didn't have the one up there for you. We're going to write the symbol for the element. So that's the capital C and the little l.
Lowercase l. Got it. Got my CL.
Now this is the most commonly missed element for the entire
New York State.
Here. Yeah, I mean, it's not capital C, capital I, guys.
Right, it's chlorine, Cl. That's a font issue, not what we're teaching you about right now. Second thing you got to do is you got to fill in the valence electrons. That's the outermost ones only. First two together at the top, then one at a time around the bus until you fill up the number of valence electrons that you have.
Right.
For
so
chlorine,
look it up real quick. How many do we got?
Let me look at my periodic table. Chlorine. Atomic number 17, it has 3 shells of electrons, 2, then 8, then 7. Which ones do I need, Mr. Milks?
Valence, I believe, is the outermost or last number in the electron.
The last number in the sequence, so that's the 7. Okay. So I got to put 7 dots around this chlorine
that's
somehow.
Right. We're going to put the first 2 together.
1, 2. Okay, so now I got to put 5 more dots in.
Right, but this is the key. 1 at a time around the bus.
1, 2, 3, 4, 5. How come I didn't put 3 at the top?
Well, we're not really going to get into that particular, all those rules, but I can only get 2 electrons in each orbital.
Isn't that Hund's rule or Pauli?
Something like
something.
that.
It has to do with quantum theory, which we don't have to teach you about.
And I'm not going to teach you that one's got a positive spin, one's got a negative spin,
up spin, down spin. We're not getting there. 2 electrons go in a pair, top, side, bottom, left.
Now, one key little note. If you see the 2 electrons on the top, the right and the left, we call that a pair of electrons.
There's 2.
Right. So you see the lone electron on the left.
Call that a lone pair.
Well, we call that a lone electron.
Not a lone pair, a lone electron.
Right, a lone electron. And then what do you think that electron might do, Mr. MoNaCo, if he came up across another, say, chlorine atom?
Well,
he's got 1 there. How many does he want?
We haven't gotten to that yet.
I know, but I just got to pre-shadow.
He's showing everybody that there's a gap there. There's an empty space around the chlorine. Sure. That electron's missing a partner. It's missing a buddy. Something can happen here in the future.
Sure. And that kind of information is very useful for these things.
Mm-hmm. So, that's why we make these dot diagrams, because then we can see that, oh, wow, chlorine's missing an electron there. Maybe it'll react with some other element to fill that spot.
Might have to do a whole unit on it.
Yes, we will. So let's did chlorine. We did chlorine. Let's try nitrogen. All right, my turn.
All right.
I drew N because nitrogen's N. I look on my periodic table, table S. It's got 7 protons, 2, then 5 electrons. So it's got 2 shells of electrons. I only care about the one on the outside shell.
Right, valence.
The valence shell, so that's the 5. So I got to put 5 dots around my nitrogen somehow. The rule was 2 at the top, then fill up the bus. So I put the 2 at the top, which means I have to put 3 more in.
3 more, and 1 at a time around the bus?
1 at a time around the bus, bing, bing, bing. Okay, nitrogen looks like it's got 3 lonely electrons.
Right.
Eventually, I bet you it's going to try and fill up those lonely spots. Whole unit on chemical bonding to figure that stuff out. So again, Lewis dot diagrams, essential to this unit.
Right, so we're going to do lots and lots of practice on this. The key here you need to know, if we only do valence electrons, We fill them in specifically. First two, then one at a time around the bus.
Two at the top, one around the bus until you fill up.
If you do it that way every time, life is going to be
Is there a
great.
maximum, like if you're trying these at home and you're like messing up a little bit, is there a maximum number of Lewis dots around the side of each symbol?
For our case and purposes for this year, you should never exceed 8.
So 8 is full.
8 is what we're going to call it.
So if I think there's 9 dots around the outside of this Lewis dot structure.
Apparently you read the valence
Miscounted.
electron number wrong, because
Right.
I haven't seen one that ends in 9 on the periodic table yet.
Ever.
Okay, good.
Yep, so Lewis dot diagrams is the keyword to search out there. If you search Lewis, you might find Lewis structures, which are more complex molecules and stuff like that. Ain't gonna hurt you to look at them and figure it out, but we're talking about Lewis dot diagrams of atoms and ions only. We're not talking about compounds and molecules
Hey,
yet.
we're going to use them again in Unit 4, guys, so
All right.
learn how to use them.
Thanks for watching. See ya.